Thank you all again for joining this very insightful session today, Wildfire, Smoke, and the Built Environment. This is becoming a very consistent part of operating environments in buildings across North America and really globally. They're getting much more intense and over longer periods of time. So that's why conversations like this really matter now before seasons really ramp up and there's still time to really be proactive and get ahead of it. So I'd like to introduce two incredible experts today for our panel. First is Dr. Emily Fischer. She's an atmospheric scientist and associate professor in the Department of Atmospheric Science and the School of Global Environmental Sustainability at Colorado State University. She's really going to kick us off with insights on wildfire smoke overall, a little bit of a higher level, its impacts, how air quality information can really support communities overall in being prepared. And then we'll hear from Luis Marquez, professional engineer, certified air filtration specialist supported by NAFA. He's also a part of the technical and guidelines committee with NAFA and is our VP of engineering at Blade Air. Luis will give a little bit of information on the built environment and focusing on indoor air quality and practical strategies for filtration and mitigation overall. So with that, I'll hand over to Emily to kick us off and we'll get started.
So I'm Emily Fischer. I'm a professor at Colorado State University in the Atmospheric Science Department, and my team leads both field measurements of smoke and its composition, and also interventions to help communities prepare for wildfire seasons. So I think you're joining this call because you know that wildfire smoke is not great to breathe, right? It impacts, it increases asthma attacks, has adverse pregnancy outcomes, exacerbates COPD, causes a variety of cardiovascular and respiratory health effects that end up in increased morbidity and mortality for society. But how do we make sure that people take the information and that we have and sort of proactive management strategies that are within their locus of control in order to mitigate those impacts for their families? So how do we sort of convince them when and how to create a clean airspace for themselves? What I'm going to just talk about, which I think will be good fodder for questions at the end, is a communication centered grant that we had at CSU that was funded by the EPA. And so this is work that represents atmospheric scientists, communication scientists, and epidemiologists all working together to figure this out. So I live in the Front Range, right? And this area people are frequently exposed to both smoke and ozone, and limited air quality communication efforts have been initiated in this area. And so our work in this particular context was tailored to outdoor workers and those living in manufactured homes. We worked over the course of almost 5 years to develop communication strategies that resonate with lived experience and sort of the immediate environments of these groups. So communication around smoke really needs to be targeted at specific people. I won't talk about it today, but the other thing that we did was assess the predictability of wildfire smoke throughout the Front Range. We worked with city outdoor workers. We did the communication scientists did formative research, did focus groups with employees, interviewed supervisors within the city of Fort Collins, outdoor worker teams. They analyzed those things and developed a social marketing strategy specific to outdoor workers, and then implemented and tested a campaign of communication. And these materials are available for groups that would want to use them. So this went it's a full-on study that went from control group, pre-season surveys, all the way to post-wildfire season surveys with a communication campaign focused on wildfire smoke in the center. So for this group, the recommendations were actually take more frequent breaks, bring their work inside, right, into a clean airspace, reduce or limit the intensity of tasks, postpone or reschedule high intensity tasks. And a large goal was to help this group monitor the air quality index for changes and encourage them to talk with supervisors. This involved digital notifications. So there were digital notifications when air quality index levels in Fort Collins were above good. Alerts were delivered at multiple times of day. This is what it looks like on the left. There was and still exists, a QR code and a landing page that helped these folks see visibility webcams, information about current air quality, and a decision chart. And so the decision chart that we've made is specific for an outdoor worker community, right? And so you can see the AQI here, which is our, yardstick of air quality, but it's the interpretation and actions are specific to outdoor work activities. And they go from continue with regular outdoor work and examples of activities by intensity, and to, under hazardous conditions where you should be avoiding outdoor activity at all or fully. And we made them for both the workers themselves and for supervisors. What this looked like, so do you want recommendations for your work today? This is where the current AQI is. This is where it's going. And, you should continue. There were constant reminders for people to have air quality information at the center of their decision making. So that looked like stickers, that looked like magnets that were in the break rooms and the indoor spaces to remind people what was happening outside and whether they should try to return earlier to an indoor clean environment. This increased information seeking and increased overall knowledge. And what was important about this is that this air quality management was specific to the individual workplace and inside a culture of safety. The second community that we worked with was manufactured home communities. The process was similar, but there was a lot more relationship building at the start. So that formative research step involved interviews with community residents and leaders and a lot of relationship building in both English and Spanish. Then there was a co-development. It ended sort of with a co-development of communication materials that are specific to these communities. So this is what this looked like in manufactured home communities. Much of this work happened in the Boulder area. This is our team visiting resource fairs, beginning relationship building between the university and manufactured home residents in this area. And so it was interviews, co-creation to develop materials that center on wildfire smoke and management. We did a lot of editing and revision. We came back to the community to iterate. And so at the end of this, the communication materials around smoke and protecting themselves was actually materials that were really owned both by the community and by the research team. And at the end, these residents and leaders participated in the distribution of these communication materials to their communities. What we found is that we went through trusted community channels. We had very specific health protective actions. And in this case, this focused on box fan filters and swamp cooler environments. So manufactured homes typically don't have air conditioning, don't have central AC systems, and may not have access to sufficient power, either for financial or logistical reasons. So we taught about using box fan filters and swamp coolers in these environments. And in these types of homes, there are many competing concerns, and there's a finite pool of worry. Things that also come up are water quality, windstorms, idling cars, traffic, things like that. So this is what this looked like. We provided information on all types of cooling systems, fan systems, and tried to understand how much people understood about the health impacts, and came up with a decision tree. And this is an example of this getting iterated in Spanish. And then held community meetings to discuss the distribution methods, after iterating on the materials. And this now looks like a decision tree for setting up home filtration and how to sort of move through that, given what your home looks like. Again, we had, so we were sending out alerts and then doing at that time, a lot of in-person communication. What we found there was that these text alerts are useful, but can actually leave people feeling helpless about sort of the continuous poor quality, particularly in the Front Range, right? This is an area where we have ozone almost daily, and elevated ozone almost daily in the summer, and that's sort of peppered in with wildfire smoke. It was important that the information on how to filter your air was brought in with tools, the general education air quality tools, so magnets, brochures, and these are things that can facilitate conversations with neighbors and community leaders. And this sort of process helped us have community leaders express more interest in wanting to learn more about air quality and continuing to pay attention to it throughout the summer. So that's what I just wanted to share with you. I'm also happy to take questions about anything else related to smoke composition or indoor air, but I'll pass it on to our next speaker.
Thank you, Dr. Fischer. I think it's very nice and very important to highlight that communication aspect of the wildfire and the air quality, because that's where it really starts. And I think that's the importance of us having this conversation here, is informing as many people as possible to sort of the risk and what can be done in order to improve the situation. My name is Marquez. I'm a professional engineer and certified air filtration specialist and VP of engineering with Blade Air. So the first thing I wanted to talk about is kind of like, why does this matter? And I think it's fairly self-evident to anybody who lives certainly in North America. The last 5 years, wildfires have been raging and burning just more and more than in any previous time in record. And so in the US, you saw more than 9 million acres burn across 65,000 fires in 2024. And then in 2025, there were even more wildfires, a little bit less acreage. And in Canada, it was in 2023 was our record year. And so the average numbers has really increased by 5% per year over the last decade. So it's not really something that's going to go away anytime soon. And so the way I like to provide in terms of wildfire is kind of a triple threat from, let's call it general pollution. So I think everybody is most familiar with PM 2.5, and that's particulates and pollutants that are 2.5 microns in average diameter. These really increase during wildfires greatly. Some studies that were done measured concentrations up to 45 times as high as compared to without a wildfire. And the reason we choose PM 2.5 is because that's what can really get inside your lungs and start to affect your breathing, especially if you're a high risk population. What is less common to track, but becoming more and more common, is particulates PM 1.0. These are even smaller particulates, and anything this size and smaller is even more dangerous because it doesn't just penetrate the lungs, but it's also able to reach the bloodstream. Now, something that was interesting is, while in normal air, these particulates make up a higher amount, they generally don't make up a higher weight. But however, during wildfires, it was actually found that they can form up to 50% more of the weight as compared to larger particles, which is certainly not the norm and just suggests the increase of concentrations for these even smaller particulates that we are less likely to be measuring. And these are oftentimes more dangerous even than the 2.5. And finally, the third threat is the gases and the VOCs. Obviously, we can all see the smoke when it's coming in, and we see those hazy days, but there's also a lot of gases that we can't even see or sometimes even smell. And so this is just kind of a chart depicting kind of the concentrations during wildfire seasons. And there were a total of 33 different VOCs that were logged in at 33 plus or minus 21 micrograms per cubic meter. And they would rise up to 50 plus or minus 28 parts per billion in non-smoke versus smoke days. 26 of those 35 VOCs showed a significant increase from their baseline. And ethanol and methanol showed the biggest increase, which is not surprising. These are compounds that are generally formed during incomplete combustion. And so as these wildfires rage, all of these gases are kind of sent out into the atmosphere. You know, we have certain guidelines, and the general macro recommendation is, wherever possible, displacement, meaning just get away from the dirty smoke. But that's impractical in a lot of cases, and that's where having good communication and other options is, recommended. Secondly, we want to reduce exposure as much as possible. That means staying indoor as much as we can, and as Dr. Fischer said, avoiding strenuous outdoor activity. And then when inside, and what I'll be talking more about is ensuring proper filtration, so we can remove these particulates and gases when you do go inside, so that you're not just bringing them in. This is some general guidelines to reduce exposure. Seek indoor spaces. Make sure you seal those indoor spaces, the windows, the cracks. We have general ASHRAE guidelines suggest bringing in outside air as like the method of cleaning air. However, this doesn't work during a wildfire. And so you actually want to reduce the outside air recirculation as much as possible and mitigating any fine particulates indoors. So avoid smoking or burning any type of fossil fuels indoors. How do we actually recommend it for air purification of particulates and mitigating the smoke? Essentially, the best thing to do for particulates is remove more of them and increase your efficiency of filtration. Most systems will have at least a MERV 8 since COVID. More and more systems have moved over to a MERV 13. But if you haven't, at least partially, it would be highly recommended to bring in MERV 13 filtration, because standard efficiency filtration or MERV 8 only somewhat reduces PM 2.5, and it's basically ineffective against anything 1.0 or smaller. And so at minimum, you'd want to have MERV 13 or higher efficiency filtration to be able to really reduce those 2.5 and smaller particulates. Where appropriate, you can use HEPA, but it is already, as Dr. Fischer alluded, a little bit impractical for some people and some communities. But wherever applicable, a HEPA filter will be greatly effective. And then one thing I'd like to call out is kind of what kind of filter. Put these labels on MERV 8, MERV 10, MERV 13, and there are a lot of what are called electrets filters out there, which have a electrostatic charge induced on them during manufacturing. But what we have found in studies is that these are greatly ineffective against the smoke because it discharges that electrical charge. So this is data from smoke from pine needles, and it just showed that whether MERV 13 or MERV 8 or MERV 10, these type of electret filters, which are charged polymer filters, became quickly ineffective after just 10 or 40 minutes, 80 minutes of use with this pine needle smoke, which is kind of the surrogate for that. And so what we could see is the non-charged polymers were able to more sustain, as well as fiberglass were able to more sustain during specific smoke. For electrostatic filtration, we would recommend having it be active or powered so that you're able to maintain that charge and it doesn't dissipate when the smokes come in. Talking more about for the gases and VOCs, as well as when you are not able to place, a MERV 13 filter in your system or you don't have the ventilation for it. Firstly, the best way to reduce VOCs and gases is to use activated carbon. The thing to note is that with activated carbon, it relies on absorption to filter gases. Depending on the gases, it may need different additives, so you have to really know what kind of filter you're putting in, but then you really want to protect it from heavy loading. These types of filters are, maximized for removing gases. They don't do as well in removing particulates. And as we mentioned, these can be 10, 45 times more dense during wildfires. And so what we would recommend is having a filter to take that heavy loading first, or at the same time as it removes those gases. And so this will allow your VOC filtration to actually be used. Another thing that we would recommend is using what ASHRAE has as the indoor air quality procedure instead of the ventilation rate. And this just means that how to properly size your equipment and your air loads in terms of using recirculated air, which can be filtrated instead of bringing in that dirty outside air. Most systems use ventilation rate procedure, which likes to bring in outdoor air in order to clean. But we know with wildfires that would be ineffective, and it would actually make the indoor air quality worse and risk the people that are inside the building. You can always take extra precautions, whether indoors or outdoors, wearing protective equipment and masks. These can be personal or N95 masks, which are well sized for those smaller particulates, especially if you are a high risk person, either young people or older folks or anybody with any respiratory illnesses or asthma. You can always bring in-room air purifiers. These are self-fan powered filters that can have HEPA, carbon, and other filtration technologies all in one single portable unit, and they can be deployed as needed or moved as required. These are especially useful for systems that cannot handle a MERV 13 filter, which will put more stress on the fans, or in places that don't have very good ventilation, which these can count as supplemental ventilation in these situations. I know Dr. Fischer mentioned, making box fan filters, and so for those of you that know, these became popular during COVID, the Corsi Rosenthal boxes. These are certainly very much would be recommended if you don't have any other options. It's a little bit cheaper way of being able to at least bring in sort of that room air purifier experience. What we would recommend is making those specifically with MERV 13 filters so that you get the appropriate filtration. And then making sure that you're replacing them accordingly. As mentioned, with all of that extra particulate and extra smoke coming in, lots of these filters would kind of dust load very quickly and may not be as effective for as longer period as they normally would. I would just leave you with this last slide in terms of just the comprehensive wildfire preparedness and just some actions to take before, during, and after. So before wildfire season, develop and review a comprehensive plan. And that's where that communication and being ready being so important. Identifying evacuation routes and destinations, where able, invest in air purification solutions, or where maybe your budget might be a little bit more tight, maybe thinking about having a Corsi Rosenthal box with some MERV 13 filters easily or readily available, as these types of filters can run out very quickly during wildfire season. Monitoring local news, emergency channels, again, that kind of communication, being active and listening to what the guidelines are. And then if you must go outside, do wear N95 or P100 respirator masks to minimize smoke exposure. And finally, that continuing to monitor air quality and follow the guidance from local health authorities and keep running your air purifiers or your CR boxes until that outdoor quality is deemed to be safe. If you are asked to evacuate and then you come back, you make sure you inspect your property for any damage and rechange those filters if they've been loaded all the way, so that you can go back to having a nice clean air. That's the end of my part of the presentation, and just happy to take questions at this time.
Thank you, Luis. Thank you, Dr. Fischer. Great presentations from you both. I see one question so far in our chat. Dr. Fischer, what tools do you recommend for measuring PM2.5 and O3? To follow up, we are a public school board in Southern Ontario, so the devices would need to be robust enough for classroom installations.
So you wouldn't measure your ozone inside your classroom. So let's talk about that first. So, and generally ozone is more of a regional pollutant. And so the EPA monitoring network for ozone is often sufficient. And so are you in Ontario, US or Ontario, Canada?
It's likely Ontario, Canada.
Okay, so I would use the Environment Canada ozone monitors for that particular pollutant. The trick about wildfire smoke is that, like our other speaker said, right, it contains a wide variety of gases and particles. So often wildfire smoke, if the fire is nearby, that'll create very large gradients in PM 2.5, very large smoke gradients. One way to know that smoke is just in the area is elevated PM 2.5. That's like distinct from your sort of variability in your urban area. So I think the Purple Air Network is a good place to go for something for a school. You could easily install a purple air sensor outside your school and inside your school to have a sense of roughly where your air quality index is with respect to PM 2.5. Given like the air quality index is a single index, single yardstick based on a single pollutant. And so I like to treat it pretty conservatively for wildfire smoke. So because there's lots of other stuff other than the PM 2.5. And so if you were to put sort of a low cost PM 2.5 sensor, and I'll drop it in the chat, something like this outside your school, that would let you know if there was elevated PM 2.5 in your area. And you could also put one inside your school to see if your ventilation systems that you have are working. So I think that's probably that's a good idea for a school type setting. I have kids who are 11 and 14, so I pull them inside and don't have them run around too much, given my kids, one of them has allergies. When the AQI is in that orange color. If you have kids who are a little bit more sensitive, you would probably want to have them listening to their bodies in that sort of yellow, darker yellow category. And I would also say that for a school, if it's an elementary school, there's some really great books from the US EPA. Those are called Why is Cocoa Orange and Why is Cocoa Red? And they explain the AQI and asthma for kids.
Luis, this one is for you. What blade air products would you recommend implementing to reduce risk for facilities that act as a community shelter during wildfires?
Yeah, so I would definitely recommend a Pro Filter, which provides MERV 13 filtration, but really depending on size, it may be necessary, especially with larger ceilings and the like with shelters. You would probably want to bring in one or two, depending more on size, air purifiers that you don't necessarily need to run under normal operations, but certainly once the wildfires are there and once your amount of people increases, deploy more of these, both from removing the wildfire smoke, but even just from how many people you have in these shelters. Generally, your air quality and your ventilation is sized for a specific amount of people. So this is where we talk about the being prepared before, is understanding how many people you would expect to get in that space, because even ignoring the wildfire at that point, the more people that you have in a tight environment, you really want to make sure that you get the proper ventilation and purification of the air. And so I would say a combination of high dust loading filtration, preferably MERV 13, but also bringing in some supplemental air purification that you can move around or deploy as necessary, depending on how many people and where they're all congregating, and really understanding what your capacity is from a airflow perspective.
Yeah, more is better. Like more filtration is better. Do the max that you can, right? Because you need to do everything to make that airspace as sealed and as clean from the outside as possible.
Next question that we have, can you advise if building filtration, MERV 8 and 13 performance life is reduced after the fire season? Would you recommend a full replacement be replaced post-fire season?
The answer is it depends. But just as a base statement, if you're not sure, yes, replace them is a general recommendation. It really depends on what kind of filtration you have there. Most MERV 8s, depending on what size, yes, I would recommend absolutely change them. MERV 13s really depends. A bag filter or our Pro filters, they're high dust holding capacity, and so they're probably okay. But if you're just on a standard flat, certainly an electret, which I wouldn't recommend to have to begin with, I would recommend changing, because at the end of the day, these are meant for standard loading. And so in 2-3 days, 1 week, you're going to get 10 times the amount what you would get on a regular day. I'm local here in Toronto, Ontario. And when we had the wildfires in both last year and in 2023, they were happening in Alberta, but it was coming and staying here because of the air currents for a week, and easily for a week our my PM sensor was reading 70 micrograms just on average, which on a normal day here it's 15 or less. And so having that consistent will certainly load any type of filter. So depends on the filtration that you have. If you have a high dust holding capacity, you're probably okay. But if you're not sure or you don't have high dust holding capacity, you definitely want to be able to replace that after the wildfire event is finished.
Thanks, Luis. What is the performance of our Pro filter for PM1?
We are under MERV 13, so I have to do the math. I think PM1 is ends up averaging around 60%. One last question there, Ava, that I saw came into the chat just a second. It's about upgrading MERV 8 to MERV 13 filter, and can HVAC systems typically handle the increase in pressure drop? Again, it depends, and in the National Air Filtration Association, we always say, recommend talking to your local certified air filtration specialist. But the reality is most HVAC systems are by design oversized. So short answer is yes, but not always. And so specifically here in Ontario, especially with schools, a lot of them were built over 50 years ago, and there was no MERV 13, and that was not really a standard. And so those fans were sized a lot smaller. And so for a lot of these, you can actually clog the system and make it worse. And so understanding what the pressure drop is, again, our filters, because we use that active electrostatic, we do offer a lower pressure drop gradients to avoid these. But regardless of system, you do want to make sure that you do have air moving, because you cannot filter and the air that doesn't pass through your filters. So if there is no, if your fan is not moving any air, doesn't matter what filtration you have zero efficiency. And so it is important to be able to move around. And so that's where in those scenarios, you can look at air purifiers and portable systems to compensate and kind of help out to the system ventilation in those specific scenarios where the fans may not be able to handle that higher filtration.
Thank you all for joining, and thank you to our two great panelists today for taking the time and being able to educate all of you and put a great presentation together. So thank yous all around, and look forward to seeing you all on the next one. Have a great afternoon, and we will see you later.
Thanks, everyone.
Thank you.